So what you're going to do is you're going to take that and go ahead and any of these that matches close to that. So the closest one that looks like the box then looks like this would look like this. Okay, so what I'm going to do is I'm going to take number 3 there, okay, that I wrote out. M minus y equals 5. Now, to match it to look like the box one, here's what I'm going to do. I'm going to multiply to get 5. From 5 to 10, I'm going to take 2. Because if I took 2 times 5, I get 10, right? Because 2 times 5 gets you 10. So, of course, what you're going to do is you're going to have to distribute everything by 2. So we're going to multiply every single term by 2. Multiply 2 by there, multiply 2 by there. What you do on the left of the equal, you do on the right of the equal. So then that means it's 2 times m, 2 times y. All right, so there you go. According to equivalence, it is equal. So answer the question, that is, Tyler's right. Yes, he is right. Tyler is right. Because when we distribute 2 to both sides, why? Because we distribute slash multiply every term from both sides and it equals 2 2m minus 2y equals 10 from 2 parentheses m minus y. Let me do a little erasing to make it look neater. M minus y equals 5. All right, number 3. Are any of these equations equivalent to one another? Basically, equivalent, a simpler way to look at it is it looks the same, it looks different. But has the same answers because being modified. Looks different slash modified. So it's being modified and then has the same answers. Okay, so here essentially this becomes an equation. So if I just subtract 6 to both sides, okay, what you do on the left, you do on the right. So 3a equals 15 minus 6 will be 9. So right off the bat, I can say, let's say here's 1, here's 2, here's 3, and here's 4. Okay, so right off the bat, I can say 1 and 2 are equivalent. Okay, over here, same thing here. Then, if I finish the problem, so continue on, if I divide both sides by 3, that means a equals to 3. Same thing here, if I divide by 3, a equals 9 divided by 3 is 3. Here, equivalence. So once I get an a equals 3, for example, right? So right here, let's begin here. A equals 3. Now, to make it look like a 5, what I can do to make it look into a 5, I can add 2. Now when I add 2, it becomes 5. But same rules. What you on the left, you have to do on the right. So if I add 2, so now this problem becomes a plus 2 equals 5. So yes, I can include 3 because it being modified, same answer, but being modified to look different. All right, so similar if I start with, let's see if it's a equals 3. Now, how am I going to modify that to make it look different, but still the same answer? So here, for me to make a 1 into a 3, excuse me, from 3 into a 1, I can divide both sides by 3. What you do on the left, I have to do it on the right. Okay, so 3 divided by 3, 1. Now, obviously here, we don't have quite know what the number in front, but remember the rule. If you don't have a coefficient, that coefficient is 1. So we can separate the fraction out 1/3 with an A. So now it looks all equivalent. It looks different, but after being modified, 1, 2, 3, and 4 are all equivalent. All right, so here, down here, are you ready for more? Here's a puzzle, and you have a little puzzle pieces, okay? So now we're gonna find what is P. I'm gonna color code, little pink, and Q with a blue. All right, so there you go, some noticeable coloration. So what can I do is instead, we know little p here, capital N plus capital N, that's another way to say 2 capital N's, right? So it's the same thing, equivalence. Here, equivalences, I can simplify a little bit more. Little m plus little m, so 1m plus 1m, just like 1n plus 1n is equivalent to 2 little m's. M and P here, I cannot combine them. They're not like terms. P and Q, capital Q, not like terms. So now the question is, what's P plus capital Q? Okay. So we do know that little p is right here, little p. So instead of little p, I can say, hey, little p is 2n. 2 big N's, okay? Capital Q, it says here, capital Q is equivalent to little m plus little p. Okay? Now, of course, so let me go ahead and draw that. Okay. But earlier we knew that. So let's see what we have so far. Does it match anything? No, not yet. Okay, so now we can take one step further. We can say, hey, we know that this little p here, that little p, like earlier, we know it is equivalent to 2n, right? So little p is equal to capital 2n, so we combine, so everything seems the same, so 2n here plus little m here equals to 2n plus 2n plus little m, so we can combine them like terms. So 4 capital N plus little m. Now, even though it looks like we're not getting any closer, because it does not look like anything yet. Okay, so now, but here's the cool thing. The cool thing is if I break it right here, little p, so I'm going to use a different color now, little p is equal to 2n, so if I double that, 2p, then I would double 2n's. 2n's. So 2 little p's equal to 4n's. So now instead of 4n, right, it matches right there. So I can say 2 little p plus m. So actually, ding, 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 we got a match. Okay. So now, opposite, if I go the other way, so right here, I'm going to modify right here, same thing. Okay. So if I have 4 n's, excuse me, n here equals to 2 m's. So if I take that number, then if I multiply it by 4, right? Everything by 4, then equivalently, 4n will equal to 8 little m's. So from here, I can also rewrite this whole thing. 4n's and now becomes 8m plus the m already got. Okay. So this equals to that. And of course, 9 and 8m plus 1m there. The coefficient is 1 if you don't have 1. So 8 plus 1 will be 9m. All right. So at least I can have this and this. Okay. Well, can we verify 3n can be the other stuff? So we still have to question this one right here, right? Question mark right there, and I have to question this one. All right, so let's start with the 3n. So 3n, does it equal to something we already knew? Well, the problem is we know that 3n and each n is equal to 2, so that means we have 6m. So 1n is equal to 2m's. Then 3n's should equivalent to 6m. And we know that the final answer has to be 9m right here. Okay? So we know that cannot be it. Same thing here. 1m, 4m. And we know each n is 2m's, right? Right here. So same thing. 4 plus 2 is 6m. And it is not equivalent to 9. So those two are not equivalent. All right, so number 63, what's acceptable? Noah is buying a pair of jeans. All right, so I'm going to notate a pair of jeans. And so we don't know what's the pair of jeans. So in this case, in the equation, that's x. Okay, we don't know how much x the jeans is. So question mark, we don't know. Then we have an equivalent of a discount coupon, 10% off. Okay, so this is the coupon minus the discount, 10% off. Okay, then we know the total price. The total price is this. Okay, then we also have to add the sales tax. So sales tax is $2.70. All right. So essentially, discuss with your partner, what does the solution to the equation mean in this situation? Well, the whole time the equation, eventually you're going to blah, 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 however you do it, you're going to eventually get an x equal. And x, in this case, eventually will give you the cost of the jeans, of a pair of jeans, based on all those given information, the orange, blue, green, and red. Part B, how can you verify that 70 is not a solution, but 60 is the solution? All right, to be a solution has to make the statement true. Has to make the statement in math, of course, statement in this case is the equation true. All right, so if we plug it in, 70, like it says there, we can it should say not a solution. So that means it will be not wrong. So if I plug it in, x, so if I plug in x is 70, everywhere I see x, I'm going to put in 70. So I'm going to write an equation here, x minus 0.1 or 0.1x plus 2.70 equals 56.70. And instead of x, I'm going to now put in 70. Instead of 70 minus 0.1 times 70. You can say times, so just parentheses times 70 plus 2.70 equals 56.70. Okay, so now I can use a basic calculator or I can use Desmos, which is allowed on your test. So I'm going to use the Desmos app. Okay, that should be, you should be allowed to use that. So I have it already here. So I'm going to type in the equation. So start from the equation here on the bottom. 70 minus 0.1 times, against x is 70, plus 270, 2.70. Does it equal to 56 on the bottom here, the question mark? Does it equal to 56, 70? And as you can see there, no, it equals to 65.70. So when you do that, the calculator gets you 65.70 or 70. So is it an equation? So is it a solution? No. 70 is not a solution. All right, now instead we're gonna try 60 because allegedly 60 says right here, it says 60 should be solution. All right, so same problem on Desmos. So right here, 60, follow the same steps. Instead x, now the pair of jeans is $60 minus 10%, so 0.1 times $60, the pair of jeans, plus the $200.70 taxes. And as you can see there, it does equal to 56.70. So on the other side, you can say yes, 60 is the solution. Blah, blah, blah. All right. So we using Desmos calculator. Okay, done. All right, so here are some equations that are related to this. So that's the original equation. So pair of jeans, 10% discount plus 2.70 equals 56.7. Each equation is result of performing one or more moves on the original equation. Each can be interpreted in terms of Noah's purchase. For each equation, determine either what move was made or how the equation could be interpreted. Some examples are given here. Then check if 60 is the solution of the equation. All right, so, well, what's the difference? So remember, what's the difference here? So this is the original. So what did we do to change it? So if you remember, that is, this is a 1, coefficient of a 1. Now the coefficient is not 1 anymore, it is 100. So what math did you do to get from 1 to 100? And whatever you do, it has to be equivalent. And the original was, so let me write 1x minus 0.1x plus 2.70 equals 56.70. So what did we do differently? All right, well, big clue. Every number is much bigger. How much bigger? Well, not too hard, hopefully. If I multiply everything by 100, then it will get you this. So if I multiply every single one by 100, it will get you here. So what was done? Multiply. The proper wording is multiply the equation by 100. Okay, so what you do on the left, you do it on the right of the equal. Okay, so that's your equal sign. So interpretation, like it says, instead of y100, well, if you move everything, now it's not dollars, traditional dollars anymore, it's now pennies, right? So money, the equation now is expressed in pennies. In other words, 5,670 cents is equal to $556.70. Okay, so cents or $56.70. Same solution to demonstrate that. So I can do the same. So right here, I'm going to take the equation. So 60. I'm going to type in 60 instead of now, new equation instead of, so we still have 60. Correction. So 0. Okay, so here's the equation. So 100 times 60 minus 0.1 times. Now, because it's not 0.1 anymore, when we multiply by 100, it equals to 10, right? So minus 10x times minus 10 times 60, and it's not $2.70, it's now 270 cents. And does it equal to 56.70? Yes, it does. Right there. So, same solution? Yes. It does equal to 56.70 cents. All right. All right, so same thing again. So our original equation, start with the original, x minus 0.1, x plus 270 equals 56.70. So what changed? So what was done? So it says so right here, what you did was take $2.70, subtract from both sides. So that's what you did. You subtract $2.70. I'm going to do a different color. Minus 270 to both sides. What you do on the left, you do on the right. And when you do that, now this will become that. Okay, so interpretation, relate to the real world. Well, what is 270? If you remember, 270 was taxes, right? So interpretation, I'm taking away taxes. So tax-free. All right, so taking away taxes. So maybe a tax-free day. Okay, same solution. You can, again, so the equation we need to keep in mind, x minus 0.1x equals 54. So I'll clear this out. So x is still 60. So 60, oops, new equation. 60 minus 0.1 times 60. Does it give you 54? And it does. So yes, same solution. So let me zoom in a little bit. So right here, what was done? So the original equation, so keep in mind x minus 0.1x plus 270 equals 56.70. Okay, so what changed? Well, this is the same. So different, let me do a different color. This is the same. This is the same. Okay, so what changed? Well, what changed was these two things. What happens was, like it says here, 10% off means 90% of the original price. So that's relating to our situation. 90% of the original price plus sales tax is $56.70. Now, what math did we do? Well, if you remember, what math did we do is we combine the red part. So basically we combined the x and negative 0.1x. Combine like terms. Combine like terms. X stuff. In this case, we combine the x stuff. Okay? Combine like terms. Same solution. You can test it, but I can assure you, plugging it in, it will be the same. So yes, as long as you do something equivalent to both sides, mathematically you did something correct and nothing is wrong, then it should be right. All right, here are some equations for each equation. Determine what moves was made, how the equation could be interpreted, then check if 60 is solution. All right, so the original equation x minus 0.1x plus 270 equals 56, what was it? 56.70. Okay, so 56.70. Okay, so what changed? Well, so if this is our original, right, our holy equation, so what changed? 56 is the same. Okay, so that's the same. That's the same. That's the same. Okay, so what changed? So this is what changed, right? So now the problem is, what was done? The price after using the coupon for 10% off and before sales tax is 56.70. So here's the problem. Basically, we're taking away the sales tax. Everything stays the same, but we are taking away the sales tax. So before sales tax, okay? So if we plug it in, is it equal? So basically 270 disappeared, right? So the problem is, did we do something that's equivalent, that's fair? Did we do something that's fair? If it's not fair, then it's not going to be equivalent. All right, so let's check. So what was done? 270, the interpretation, $2, subtract $2 away from the left side of the equation. All right. So we took away $2.70 on the left side, but we didn't do that the same on the right side. So is it going to get the same? Well, let's see. So with the equation here is x minus 0.1x equals 56.70. So I'm going to clear out everything here since I don't need that. So clear. X out everything here. Clear, clear, clear. All right. So X is 60 going to work? Well, let's see. $60 minus 0.1 times 60. No tax. Remember, we took the tax away. Does it equal to 56.70? Well, unfortunately, does not, because we took out 270 and on left, but not on the right side. So therefore, no, not a solution. Not the same solution. Okay. So same thing here. Same process. Let's compare x minus 0.1 x plus 270 equals 56. But what's the difference? We got this the same. We got this the same. 270 okay, so looks like we subtract 270 like it says there, right? Subtract 270, but we add 270. Okay, so is it gonna be the same? One side was add, subtract, the other side we added 270. Well, that's what we did. So the interpretation, we take the tax away. So interpretation, take the tax away. But added to the price. Okay. So is it going to be the same price for the pair of jeans? So just keep in mind, this is the equation we need to check. X minus 0.1 x, is it equal to 59.40? All right, so here's the calculator. X, again, 60 minus, oops, let me clear that out. 60 minus 0.1 times 60. Does that equal to 59.70? Obviously, does not. It equals to 54 again. So no, because we did something that's not equal to both sides, not equivalent. So that's what happens when it's not equivalent. We didn't do the same thing. Fair. Here, what's the difference? What was done, we multiplied 2 to the left. So right here, so multiply 2 to the left. So this was the new one that we did. Okay, so 2 to the left, okay, times 2. 2 times 2 to everything on the left side of the equal. Okay. So, interpretation, what does that mean? The price of 2 pairs of jeans after the coupon 10% off and paying taxes, is it equal to 56? Well, here's the deal. We know that to be equal, the original answer, whatever you do on one side, you have to do it on the other. Or that's the otherwise it wouldn't be, right? So you multiply 2 to the left, meaning you're buying 2 pairs of jeans. Will it cost you only 56 bucks? When you buy one, it costs you 56. Now you're buying 2, it's still costing you 56. So to verify, is it the solution? Well, let's use your calculator. Here you go. To shortcut, 2 parentheses. All right. Oops, let me go clear that out. So part 2 here. So 2 parentheses. Original answer, the original pair of jeans was 60 bucks minus 10% tax times 60 plus the $2.70 tax. Does it equal to $56? No, it is not. Obviously, it's double, more than 100 bucks, right? 113. So is it the same solution? No. Which of the 6 equations we did, so A, B, C, D, E, F, which equation is equivalent to the original? Well, which one is equivalent? Essentially, which one is a yes, the same cost? Well, D, E, and F, wrong, doesn't have it. All right, but equation B, and equation C is equal. So equation A, B, and C are equivalent. Because when we checked, because 60 is the solution for equations A, B, and C.